Now the first problem is trace the curve y square into 2a minus x equal to x cube. First of all, this curve has name. This curve is known as cissoid of Dickel. Okay, this is the name of this curve. Now what we need to do, we need to go by rules. Okay, so what is the first rule? So first of all, how can we write this equation? This equation can be written as y square equal to x cube upon 2a minus x. Okay, give this as equation number 1. Now what is rule 1? Rule 1 is symmetry. Okay, so now we need to check the symmetry. Okay, so what is the, observe this equation. Okay, so here we have even powers of y everywhere, right? Only y. So first, as even powers of y everywhere, what we can say, even powers of y everywhere, therefore curve is symmetric about x-axis. Okay, now for the next symmetries, what we need to do, yes, it is not symmetric about y-axis because no even powers of x, as well as it is not symmetric about both axes. So next point of symmetry is symmetry in opposite quadrant. So is it possible? Because y is equal to, if you replace y by minus y and x by minus x, do you get the same equation? No, because here if you replace x by minus x, this becomes 2a plus x. So this is not the same equation, so that symmetry will not occur. Okay, see, if you replace y by minus y, this is y square, it will become x by minus x, it will become minus x cube upon 2a, again it becomes, so this is not the same equation anymore. Okay, so this is not symmetric in opposite quadrant. Now symmetry about line y is equal to, if you replace y by x and x by y, so what you will get, x square equal to y cube upon 2a minus y. Again this is not the same equation. Okay, so this is not symmetric about line y is equal to x. Similarly, it is not symmetric about line y is equal to minus x. Okay, so we got the symmetry only about x-axis. Now rule 2 is point of intersections. Okay, point of intersection. So what is point of intersection? First one, we need to check whether it passes through origin. So what is the condition for passing through origin? As equation should not contain absolute constant. So does this equation contains absolute constant? No, because 2a is the constant, but 2a has the coefficient y square. So this equation does not contain any absolute constant, therefore it passes through origin. Okay, now for the intersection with coordinate axis, so for intersection with x-axis, what we need to do, for intersection with x-axis, what we will do, put y is equal to 0. Now if you put y is equal to 0, this will be, see, 0 equal to x cube upon 2a minus x, that is x cube equal to 0, that is x equal to 0. Okay, x equal to 0, therefore you get 0.00. Now similarly, if you put x equal to 0 in the given equation, what you will get, y square equal to 0 upon this, so it is 0. So this curve intersect to coordinates axis, this curve intersect with coordinate axis only at 0, 0. Okay, Now next is tangent. Rule 3 is tangent. Okay, so see, tangent, first we need to find tangent at origin. As the curve passes through origin, we should observe the tangent at origin. So tangent at origin can be, what is the rule to find tangent at origin? Tangent at origin can be obtained by equating to 0 the lowest degree term. Lowest degree terms in the equation. Okay, so what is our equation? Y square equal to y square into 2a minus x equal to x cube. So if you multiply, this is 2ay square minus xy square equal to x cube. What is the lowest degree term? This term has degree 2, this has degree 3, and this has degree 3. So lowest degree term is, therefore lowest degree term is 2a y square equal to 0, that is y square equal to 0, that is y is equal to 0. As we have got y square equal to 0, that means two branches of the curve passes through 0. Okay, so that we have to write it over here as y square equal to 0. Y equal to 0 is a double point. Okay, because two branches of the curve passes through it. Now it is a double point, so we need to find whether it is a, now see, y equal to 0 means x-axis is tangent. Okay, so x-axis is tangent at y equal to 0, means since it is a double point, two branches of curve passes through this point, but tangent is only one. Now two branches of curve passes through this curve and tangent is only one, so this is the definition of cusp. Okay, that we have seen. So see here, a double point is called cusp if the tangent at it to the two branches of the curve are coincident, and it looks like this. So cusp looks like this. Okay, now see, so we have found the tangent at origin. Now the next is we need to find, yes, we need to find asymptote. Okay, so that we have to write here, since we have coincident tangent at origin, so origin is cusp. Okay, now rule 4 is asymptote. Asymptote is what? Tangent at infinity. So how to find asymptote? Asymptote, first we will find asymptote parallel to y-axis. Okay, so what is the condition? Equate to 0. What we need to equate to 0? The coefficient of highest power of y. Correct? So now, what is highest power of y in the given equation? What is highest power of, what is the equation? C, y square into 2a minus x equal to x cube. So what is highest power of y? Y square. What is its coefficient? 2a minus x. So what we need to do? Equate it to 0. 2a minus x equal to 0, that is x is equal to 2a. So this is the asymptote parallel to y-axis. Okay, now for asymptote parallel to x-axis, what we need to do? Equate the coefficient of highest degree term of x. What is highest degree term of x? X cube, but its coefficient is constant, which is 1. So we cannot equate 1 to 0. So no asymptote parallel to x-axis. Okay, so there is only one asymptote parallel to y-axis. Now the last one is region of absence. Okay, rule number 5, region of absence. So now see, what is equation? Y square equal to y square into 2a minus x equal to x cube. That is y square equal to x cube upon 2a minus x. Now see, how do we find region of absence? If for some value of x, y square becomes negative. So now see, if x becomes negative number, means if x is negative, x cube is also negative, right? So x cube negative means y square will become negative. So what is first? For x less than 0, that is x is negative means x less than 0, y square becomes negative, correct? Therefore curve does not exist for x less than 0. Okay, means curve will not exist for x less than 0. Second, now if this x becomes suppose 3a, okay, if this x becomes 3a, what you will get? Y square equal to 3a cube upon 2a minus 3, that is y square equal to 3a cube upon this 2a minus 3 is minus a, so again y square becomes negative. That means for all the numbers greater than 2a, again y square becomes negative. So for x greater than 2a, y square becomes negative. Therefore curve does not exist for x greater than 2a, means whatever the curve exists only for curve lies between 0 less than x less than 2a. Now we will try to draw the curve. Okay, so see, now what we have got, it is symmetric about x-axis. Okay, so whatever the curve we will draw in the upper part will be same in the lower part. Now what is the first thing we have got about this curve is, see, symmetry. Now point of intersection means it passes through origin. Okay, the curve intersects and origin. Okay, now see, tangent at origin means tangent at origin is y x-axis. X-axis is tangent at y equal to 0 and origin is a cusp. Cusp look like this, means origin is a cusp and x-axis is a tangent. Means for two branches we have this common tangent, right? For these two branches we have common tangent. That means it will look like this. Okay, so we have a cusp at origin and the common tangent is x-axis. X-axis, that is y equal to 0, common tangent. Okay, that now we are able to draw up to this point only. Now the next is asymptote. Asymptote parallel to y-axis. What is the asymptote we have got? X equal to 2a. So x equal to 2a is the line passing through x-axis and parallel to y-axis. Okay, so this is x equal to 2a, which is asymptote. Okay, this will be the tangent when it goes to infinity. Okay, now this is what we have got. Now again, what is region of absence for x less than 0? Means for this, before origin there will be no curve, and for x greater than 2a means after this line there will be no curve. So curve lies only between the 0 to 2a. Okay, now after that curve can take any shape, right? So what we need to do, we need to find the in between points. For that we need to find the in. Now we know that it exists up to x equal to 2a, so we will find the point for x is equal to a. Okay, so for x equal to a, what is given equation? Y square into 2a minus x equal to x cube. So substitute x equal to a, y square into 2a minus a equal to a cube, correct? So y square into a is equal to a cube. So y square a minus a cube equal to 0. That is a into y square minus a square equal to 0. That is y square equal to a square. So y is equal to plus minus a. Means for x equal to a, what we have got, point on the curve are AA and A minus A. So AA will lie somewhat over here. Okay, so A and A minus A will lie somewhere over here. Okay, so this curve will pass through them. Okay, and it will go like this. Okay, so this is the curve we have got. Okay, now see, you can see here, this is the cusp, this is tangent and infinity, that is asymptote, this is tangent at origin, and it is symmetric about x-axis. Okay, so this is how you need to trace the curve.